Morning, everybody. We are here in Manhattan, Kansas, in the center of the United States, pretty close to the actual center of the lower 48 states. And in the background, we have a large dammed lake, Tuttle Creek Dam, large dammed reservoir that is here for flooding prevention purposes. But that's not why we are here this morning. Look around with me if you want. Sun is just rising over the horizon, and in the back, I hope you see clouds in the valley of the Kansas River, which is below us, which is topographically below us. It's also a few miles away, and that's what we need to talk about here. So this is a glorious early October morning. Sun, as you saw, is just coming up. And it's been a cold night. How do I know? Well, one, it's still quite cold right now. Two, there are no clouds in the sky. Yeah, some over there, but largely a clear sky overnight. Stars were visible, and that means that the Earth's surface has an easy job of cooling down. You recall, hopefully, the long-wave radiation has nothing to prevent it from going out to space if there are no clouds. If there are clouds, the clouds do take up some of that long-wave radiation and then send it right back. So clear nights, easy cool down, and then cold Earth surface, which then subsequently cools down the air that is above it, and then that air on occasion can cool down so much that it gets colder than its dew point temperature. Recall, dew point temperature, that is the temperature that if you reach it, or if you go under it, does no longer allow you to hold all the moisture as gas, and some of it has to become tiny droplets of water, which we see as fog in the back today. It'll burn off in a few hours. This is going to actually be a somewhat warm fall day. It will burn off. I say burn off, but it really is just warming up the air, of course, so that it goes above the dew point temperature again. Now, why do we see that only in the lower parts of the landscape? Why, for instance, where I am, we do not have any fog? Because all of those places have identical starry nights, identically cold conditions overnight. One would expect, right? And the reason for that is something that's called cold air drainage. Places like this, where I am, are relatively high in the landscape. Once cold air gets produced, it will behave like any heavier liquid over a cooler liquid, and it will start to move down. Just like water would flow down over a landscape, also that cold air would flow down over a landscape, ends up in the lowest parts, and that in our case is the valley of the Kansas River. So cold air drainage helps make fog, if you want, and helps make fog appear only in the lowest part of the landscape. Then why don't we see it right over there at Tuttle Creek Lake? Because that is a local low in the landscape as well. The reason for that is this is fall. The water is still relatively warm from summer, and so even if it cools down somewhat overnight with a clear night, it will not cool down to the extent that it is so cold that it cools down the air to under its dew point temperature. Now this will be reversed in spring when the water of the lake is relatively cold, and so it has an easier time of cooling down the air above it, and at that point in the year you will see fog happen really easily over the lake, even easier than behind me in the valley of the Kansas River. With that, have a great day and see you around.